Hello everyone, welcome to my calculus lecture. In this lecture, we continue to study how to calculate limits. We are going to discuss limits of 0 over 0 type indeterminate form. In fact, in one of my earlier lectures, we briefly discussed this type of limit. So when we have a limit of a rational function, so in this case, p of x and q of x, these are polynomials, right? Where uh, limit of p of x and also limit of q of x, they both approach 0, right? So we have 0 over 0 type indeterminate form. This type of limits can be easily evaluated by factoring. So here is an example. Uh, Evaluate a limit of x squared plus 3x plus 2 all over x squared minus x minus 2 when x approaches negative 1. Okay, so in order to work on this example, let us switch to my notepad. Okay, so what we have here is limit uh, of the rational function x squared plus 3x plus 2 all over x squared minus x minus 2 and x approaches negative 1, right? So we are going to factor, well, before we do that, let us see what happens when you plug in x equals negative 1, right? For the numerator and also for the denominator. See what happens. So in case of a numerator, right, when you plug in x equals negative 1, we have so negative 1 squared plus 3 times negative 1 plus 2. So what do we get? This is 1, that's negative 3 plus 2, that becomes 0, right? And for the denominator, right, when you plug in x equals negative 1, we have negative 1 squared minus negative 1 minus 2. So that's 1, negative, negative, that becomes positive 1, and I have minus 2. Altogether, that becomes 0 again. So this is a 0 over 0 type. Okay, this is a 0 over 0 type indeterminate form. Okay, so what do? We factor the numerator and the denominator. Okay. So the first one, it can be easily factored into, what is that? X plus 1 times x plus 2. The second one is factored to x minus 2, x plus 1. So you see that the numerator and the denominator have a common factor, which is x plus 1, right? So this is the factor that makes both the numerator and the denominator equal to 0 when you plug in x equals to -1, right? And again, when x approaches -1, right, that means x gets closer and closer, indefinitely to -1, but it never becomes -1, right? Again, the uh, ridiculous sounding like what analogy I was using, thinking about like, the flying arrow, getting closer and closer to the target, but which never, the hits the target, right? So that's the situation. So since x is never equal to -1, right? X plus 1 is never equal to 0. It just gets very close to 0, but it is never equal to 0. As long as it is not 0, we can divide, right? Any number by x plus 1, okay? Or polynomial, right? In this case. So we divide the numerator and the denominator by x plus 1, okay? So this leaves us, right? So limit x goes to -1, x plus 2 over x minus 2. Okay, it is no longer 0 over 0 type because that factor has gone, right? Which makes the numerator and the denominator uh, 0, right? So it is no longer 0 over 0 type. And when you plug in x equals -1, we get what? -1 plus 2, that's going to be 1 over -1 minus 2, -3. So the answer, right, the limit is -1/3, -1/3. Right. Okay, so this is the final answer. Okay, now back to my lecture slide. So 0 over 0 type limits are not necessarily like the limits of rational functions. Okay, there are other types of the 0 over 0 type indeterminate forms. So next type we want to talk about is the limits of functions containing a radical symbol, square root. Okay, so this funny looking symbol is actually square root. Okay, right. This is not a difficult type either, right? This type of limits can be evaluated by rationalizing, right? Rationalizing the denominator or the numerator, depending on which one contains the radical symbol. Okay. All right. So here's an example. Okay. So we want to evaluate uh, limit of 4 minus x squared. So that's polynomial, but the numerator, so all over 3 minus square root of x squared plus 5. Okay, and we want to calculate limit of this function when x approaches to when x approaches the number 2. Okay, right. All right, so to work on it, let's move to my notepad. So here we have the limit, okay? Limit x approaches number 2, 4 minus x squared all over 3 minus square root of x squared plus 5. Okay, so first we are going to check whether this is a like 0 over 0 type indeterminate form. Okay, so the top part is clear, right? When x equals 2, 4 minus 2 squared 4, so it becomes 0. What about down here, like the bottom part? So when x equals 2, we have 3 minus the square root of 2 squared, right? 2 squared plus 5. 2 squared is 4. 4 plus 5 is 9, so square root of 9 is 3, right? So 3 minus 3, this equals 0 again, right? Okay. All right. So in this case, this limit can be evaluated, as I mentioned, by rationalizing. So for this particular example, the denominator has a radical sign, so by rationalizing the denominator, we can evaluate this. So 4 minus x squared all over 3 minus square root of x squared plus 5. That's the original function. When you have a rational function, just like a fraction, you can multiply the numerator and the denominator by the same number, right? In case of a rational, it's not a rational function actually. It's not a rational function, but the function divided by another function, same principle. Okay, so you can multiply the numerator and the denominator by the same function. So what's the function? In this case, the conjugate of this numerator. I mean, the denominator. What is the conjugation? Conjugation is, so we have 3 minus square root of x squared plus 5, right? Conjugation is 3 plus square root of x squared plus 5 all over, same thing, right? 3 plus square root of x squared plus 5. Okay, so these two guys, as you may recall, these two guys are called conjugate of each other, right? So this guy is conjugate of this guy is conjugate of the other guy, right? Conjugate. Okay, so we continue our calculation. Limit x approaches number 2. So top part, not much to do, but we can first write it down as 4 minus x squared times 3 plus square root of x squared plus 5. Okay, don't, by the way, try to like FOIL this, the multiply like, each terms. You are going to make things, pretty complicated and, yeah, actually that's not going to help. So leave it like that. And moreover, these two guys, so I'm going to, for now, just write down, okay, one next to the other. So x squared plus 5, here I have a 3 plus square root of x squared plus 5. There is not much we can do about, again, the numerator part, but there's something we can do about this, okay? This is the reason why, we actually try to, multiply the denominator by its conjugate, okay? Remember this, well-known formula, okay? So a plus b times a minus b equals a squared minus b squared, okay? This is very important formula, okay? It comes in handy. It's simple, but it comes in handy uh, in many cases. Okay, so because of this property, this formula, in fact, we can rationalize. Rationalize means that you are getting rid of the radical sign. That's what we mean by, rationalizing. So we continue. So this is the limit. X approaches number 2. So top part stays same. 4 minus x squared times 3 plus square root of x squared plus 5. So these two, using this formula, it becomes what? A squared, 3 squared, 9, minus b squared. Square root of x squared plus 5 squared, right? Which removes, right, the radical sign. So that leaves us, in fact, right? So together, only x squared plus 5. So, that all together, right, that becomes 4 minus x squared. Okay? So instead of writing that in the next line, I'm going to just simply write, okay, 4 minus x squared. Okay? So that's what happens. Okay. Right, so you see that? I have 4 minus x squared in the numerator and also 4 minus x squared in the denominator. That's what makes it, both the numerator and the denominator 0. Okay, when x equals to 2. Okay, so, and also, again, the same thing goes here. X is approaching the number 2, so x is never equal to 2, although it gets closer and closer and closer indefinitely, okay, to the number 2. So 4 minus x squared is never equal to 0, no matter how close x is, to the number 2. Okay, so we can divide top and bottom by this 4 minus x squared. So leaving us, this leaves us limit x goes to 2, 3 plus square root of x squared plus 5. Okay? Now, when x approaches the number 2, right? So, inside the radical, that gets closer to 2 squared plus 5, right? So 2, right? So 2 squared plus 5, right? So that's it, 9, okay, that's 9. So square root of 9 is 3, so 3 plus 3 equals, in this case, 6. Okay, all good, right? So this is how we can calculate this type of limit. Okay, so going back to our slides. All right, so as usual, more details of my discussion here can be found in my lecture note at the following address. Okay, so like I said before, right? So this address is hyperlinked, so you don't even have to copy. You just click on it, so it'll take you there. Or if you are interested in visiting my main blogger site, this word blogger is also hyperlinked. So you just need to locate your cursor here and then click on it. So it'll take you there also. Okay, right. And I think that's it. Yeah, right. So thank you for watching, and I'll see you next time. Okay, bye bye.